Okay, so today we're going to talk about recurring decimals as well as just a little bit about decimals and fractions. We did that last week, but I was briefly go over. So a decimal is a rational number. So remember we're talking about rationals, as in numbers that can be written as a fraction, a over b. A decimal is a rational number if it's either terminating, which means it comes to an end, it has a limited number of decimal places, so you know, 5, 10, or 100, if you have a million decimal places, as long as it finishes at a million, it's a rational number. Or if it's repeating and non-terminating. So you can go on forever, but if it has a repeating pattern, or one number is repeated over and over again, some at the end of it, then it's a rational number. So 0.1 repeater is a rational number. 0.6222222 that goes on forever is a rational number. 0.125, 125, 125, 125 where it goes on forever and 125 pattern, that's also rational. You can have any number of patterns. Just as long as it's repeating, it's going to be a rational number. And just a notation thing, when you write a recurring decimal, you place a dot above the number that is repeating. Or if it's a pattern that's repeating, you place a dot above the first and the last of the pattern. So for example, we have I'm just going to close this out for 2 seconds. Always wants me to restart it. So you might have 0.2 repeater, you put a dot above the 2. Okay? You might have 0.13 repeater, that means it's 0.1333333. Okay, 3 is repeating forever. Or you might have 0.15, and if the 1 and the 5 are repeating over and over again, you put a dot above both. That means this pattern is repeating 15, 15, 15. Or if you have a longer pattern, you might have 1.6380. You put a dot above the first of the pattern and above the last. So 1.6380 is the pattern that continues and repeats over and over. Okay? So that's just the notation thing that we need to be familiar with. You've seen it before, making sure that you're familiar with that. Okay? Now, next bit I'm just going to go over. After this, don't write the 3 types of decimals. I just want you to listen to what they are. You've come across them before. We've spoken about them before. I just want you to have a look at the 3 types of decimals. And then we're going to talk today much more about recurring decimals. So just finish copying this down. Move it up a little bit. So there's 3 types of decimals. There's terminating decimals, we've spoken about. That's a rational number. Decimal places come to an end. Okay? That's the second one here. Finite number of decimal places. There's recurring, which has an infinite number of decimal places. Goes on forever, but it has a repeating pattern or a repeating numeral. And then non-recurring and non-terminating, that is an irrational number. Okay, so you can't write that as a fraction because it goes on forever and there's no pattern to it. So numbers like pi is an irrational number. It has a non-terminating, non-recurring decimal. It goes on and on without any set pattern that repeats. Okay, the square root of 2 is an irrational number. If you put it in your calculator, you get 8 decimal places of just random numbers, and that goes on forever. It just seems to be random numbers that come up. No pattern to it. Okay, they're irrational decimals. Alright, and then to express, so you can start writing from here again. I think it'll be just a couple of notes that you need to take. Today, mainly we'll be just looking at examples because we really need to show you the method. Okay, can I go up to here? Has people written this one? Is that right? Okay, so to express fraction as a decimal, you divide the numerator by the denominator. And that's what a fraction is, actually a division operation. It's just another way of writing somewhat the numerator divided by the denominator. Okay, but it's just a different notation. So you have 3 over 4, or 3/4. 3 divided by 4, if you put that into your calculator, you get 0.75. Okay, so that's what 3/4 equals as a decimal. 0.75. Okay, so you can do that for any fraction. The other way to do it was stroke the value. If you type the fraction in and press equals and then you press the fraction button, it will convert between a decimal and a fraction over and over. Okay, going back and forth between the two. Okay, you don't need to write this one. Just listen to it, the 3 types of decimals, so I'll go all the way up here. Alright. So to express a decimal of a fraction, make it into a fraction over 100 or 1,000 or 10,000 or over 10 or whatever it might be. We talked about last time the place values. The value that it holds on its decimal place. It could be first decimal place, second, tenths, hundredths, or thousandths. You put it over 10 or 100 or 1,000 and then you simplify. Right, so 0.4, the place value is 4 over 10, which is 2/5. 0.74 is 74 over 100, so you can simplify that to 37 over 50, or you have 0.435, which is 435 over 1,000, which is 87 over 200. I think we looked at this last. Okay, so it makes you familiar. You're just putting it over. If it's 2 decimal places, it's over 100. If it's 3 decimal places, it's over 1,000. If it's 1 decimal place, it's over 10. Alright, if it's 4 decimal places, it's going to be over 10,000. And then you simplify. Alright? Worst comes to worst, not worst comes to worst. Type in the decimal, press equals, press the fraction button, and it will do it for you. Okay? And this is important when comparing the value of fraction and decimals, you need to convert from those to decimals. They have to be the same form. Okay, you can't compare a fraction really unless you know what it is in the decimal. And so you're going to make sure that it's converting, so you know how to do it. Okay? So now we're going to get on to the main part of this lesson, which is converting recurring decimals into fractions. Now the thing about recurring decimals, you cannot input them into a calculator. You can do up to 8 decimal places. You can do 0.11111. Can someone do that? Do 0.111 as many times as you can. And press equals, and then press the fraction key and see what happens. Does it work? Doesn't do anything. You can't handle recurring decimals because we're actually talking about something to do with infinite number of decimal places, which is actually quite difficult for this calculator. Although they're very good. Okay, so we need to do it manually, and we use a simple method of using algebra, and then we'll be able to do it. Okay? So let's move it up. So recurring, you don't need to write this part, we've already looked at it. Recurring decimals are rational, and so can be written as fractions, but there is no way to input recurring decimals into a calculator, which is what I just said. So we need to follow this method. Just write this sentence. This method involves cancelling out the repeating part of the decimal using simple algebra. Okay? Now it is simple algebra, but to sort of use it with a bit of, this is a nice method. Okay? Whoever came up with this quite a clever person, it's a bit of finesse, quite a clever sort of thought behind it. This is a nice method that we have. So I'll just go right to the top, just writing the heading, and then doing this sentence here, this one. Don't need to write this way, you write this one. And then I'll show you these couple of examples. So when I do the examples, please just listen and just look at what I'm doing, and then we can come back and write it. So that's actually quite good. You listen once, watch how I'm doing it, and then you come back and write it yourself, see if you miss a line. Okay, so I'll give you time after each one to write it out. So don't worry about getting it down, I just want you to listen. So once you finish the sentence, can I move it up? Well, I'll move it up to where the sentence is, okay? And I've got space to do this one. Alright, so I want you to all listen and look at what I'm doing. Okay, so the first thing we have, we've got 0.1 repeater. Alright, this is also 0.1 repeater. And so what we need to do is, we want to give it a name. Okay, and the name I'm going to give it is N, the letter N. I'm going to say, does anyone remember the method? We did this last year. Sound familiar? N's and recurring decimals? No? Okay, good. Well, we're going to go over it again. Hopefully coming back to it after a few months will help us. So I'm going to call n 0.1111. Okay, and the reason I'm writing it out will become apparent in a moment. That's the name of the unit. You can call it anything from x, you can call it pineapple, whatever you want. So I'm going to call it n. Now, I'm going to say, well, what happens to this number? What happens to 0.11 repeater when I multiply it by 10? What do I get when I multiply 0.1111 by 10? What do I get? What happens when you multiply something by 10? It moves up. The decimal point moves up, so H what are we going to get? 1.1111. Okay, so I can say, well, 10n, which is 10 times n, is equal to 1.11111. Goes on forever. Okay. Anyone, you understand what I've done here? I've just multiplied this number by 10. So I've got n, which is this, and I've got 10n, which is that. The next step I'm going to do is this, 10n minus n. I'm going to do the right-hand side in a sec. What's 10n minus n? 9n. It's not 10, it's 9n. You don't just get rid of the n's. Okay, so it's 9n. Now what I'm going to do is, 10n is this, and n is this one. So what I'm going to do, I'm going to line them up over here. 1.1111 and 0.11111 minus. When I subtract these, 1 minus 1. What's 1 minus 1? 0. They cancel out. What's 1 minus 1? Cancel, cancel, cancel. What am I left with? 1 minus 0, which is? 1 minus 0 is not 0. 1 minus 0 is? 1. So I'm left with 1. So what this is 10n minus n is 1.11 minus 0.1, which I've done here. So what it is the repeating part of the ones, cancels out, and I'm just left with a numeral 1, which is 1. How do I get n on its own here? Divided by 9. So if I divide both sides by 9, I get, what do I get? I get n on this side equals 1 over 9. Now I have this situation where I say, well, n is equal to this, and n is equal to this. So what's my conclusion? If n is equal to this one, 0.1 repeater, and n is equal to 1 over 9, what can I say about 0.1 repeater and 1 over 9? They're the same. So therefore, which is the 3 dots, is therefore, 0.1 repeater is equal to 1 over 9. So I found it as a fraction. Okay, go ahead and write down this method. Okay, write it down. So the idea is we're cancelling out the repeating part. Cancelling out. And you have to just multiply it by 10 or 100, depends on what kind of pattern it is, with what you multiply it by. Okay, so in this case, it's a single repeating pattern, single digits, so multiply it by 10. Okay? Multiply by 10. Because it's a single digit repeating over and over again. Let's finish writing it down. So we know that 0.1 repeater is 1 over 9. Alright, few people finished, most people finished writing it, and then move it up and do the next one. Should screw them up to here, is that right? Okay. Up to here. Next one. 0.545454 repeater. Okay, so you're repeating 5 and 4 over and over again. What we did is the same thing. We called this repeating decimal by a name. So I'm going to use n again. Okay, so n equals 0.5454. Now, the difference with this one and the first one is that the repeating pattern, how many digits does it have in the repeating pattern? Okay, so it's 2 digits, 2-digit repeating pattern. So what should I multiply by then? Yeah, 100. Because you want to shift it up 2 decimal places. Okay? We want to shift by 2 decimal places. So we want to multiply by 100. So we're going to say, well, what's 100 in? What's 100 times this? What do we get? 100 times 0.545454. Yeah, 54.5454. 54.5454 dot. Okay, so now I can do the same thing. I say, well, 100n minus n. What's 100n minus n? What is it? 99n. 99 lots of n. Good. And so 100n minus n is also 54.5454 repeater minus 0.5454. Can you see what happens? What cancels out? What's the thing that cancels out on these two? Yeah, the repeating parts. I'm going to do it one above the other. You can see it clearly. 54.54, 0.54. You subtract it. 4 they cancel out, 5 they cancel out, and I'm left with 54. So 99n equals 54. What do I have to do to get n on its own? I can't take it away. You've got 99 times n. Yeah, divide by 99. So we've got divide by 99. Both sides. So n equals 54 over 99. And this can actually simplify to 6 over 11. Thank you. 6 over 11. Okay, so 0.54 repeater is equal to 6 over 11. Alright, so writing this method down. So because, and the key point is, if you have 2-digit repeating pattern, you multiply by 100. If you have a single-digit repeating, you multiply by 10. Okay, that's going to cancel it. So shift it up, you're going to cancel it. So writing this one down, please, and then we'll move on to the last example. Alright. Last one I'm going to do. You're just watching it. So I can come back to it. Give me some space. Just listening. We've got this 0.382, A2. It repeats on and on and on. So we're going to call n, I'll do it a bit quicker this time, 3A2. Now, what's the repeating pattern? How many digits in the repeating pattern do you have? Are you sure? The repeating part. It's 2. Because the 3 just happens once, but then you have A2 that goes on forever. The repeating pattern is 2. we have 2 digits, so we multiply by 100. Multiply by 100. So what we're going to do is 100n equals 38.2828. Blah, blah, blah. So same thing again. We go, well, 100n minus n, and that's the same as the last one. That's 99 lots of n. But we also have 38.282828 minus 0.38282. So if I do it with one on top of the other here, 38.282 minus 0.382. So what cancels out? If we do it carefully, 2 minus 2, that cancels. 8 and 8, that cancels. Alright? Now we have to subtract. What's 38.2 minus 0.3? So I can do, so I get the 8, I take 1 off the 8, so we go to 7, and I add it to this 12, so that becomes 12. 12 minus 3 is 9, so 7 minus 0 is 7, so 37.9 is what we end up with. Any questions? So matching up the repeating parts, 2 digits, you multiply by 100. If it's 3 digits, you multiply by 1,000. And then you get to this point, you divide both sides by 99. 37.9 over 99. But we have a problem here. Can we have decimals as part of fractions? No. We can't have a decimal as part of a fraction. And so what do we need to do? We can round, or we don't want to round. We want to do something else. We want to change the fractions to equivalent fractions. What's the easiest way to get rid of this decimal place? I want to shift the decimal point to the right one place. What do I have to multiply it by? Times by 10, that's right. And a fraction, I can keep the value the same as long as I multiply top and bottom by 10. So I'm going to multiply the top by 10, multiply the bottom by 10, and so we get 379 over 990, which I don't think can simplify. And if you type into your calculator, you can check. So, I can just conclude that 0.382 repeater equals 379 over 990. Alright, and that's the method for recurring decimals. Best way to do it is to do it yourself. So I'm going to stop this here.